Waiting for my screen. Okay, we are back. Welcome back. It looks like 90% of people have made it back. Hopefully those that remain are merely late and not disappointed by the content so far. I do want to take a quick show of hands, though. Raise your hand if the pace we're going is about right. Raise your hand if you wish it was going faster. And raise your hand if you wish it was a more careful, slower explanation of each bit. OK, so it looks like based on that, I can go very, very slightly faster without offending the group. OK, so where we left off, we're doing a very simple Java build, but I hadn't actually built the thing yet. So let's start and do the build. Now, again, I'm just going to copy from here because I know this command works. And use, OK, yeah, this thing I already did. We have some tests in here, so I'm going to run the tests and see if the tests pass. And sure enough, they do. And use that as a reason to mention a few bits here. So the test command by default, the test subcommand of Bazel by default, is made for running like running your tests in a monorepo where you have 7,000 or 70,000 tests and so on. So by default, it really just wants to tell you like, hey, did things pass or not? I have found that when tests don't pass, I often would like to go fix them. So get to know these two settings and use them often. You will need them when tests fail. When you have tests that fail because they exceeded a test timeout, you'll need the first one. And when you have tests that fail because the testing tool threw an error message, by default, you actually won't see that error message. It'll be sitting in a log file. Like the Bazel output will just tell you, hey, a test failed, and here's a log file to go look at. This option is a real important common one to say, go ahead and print out the failure in line. And I don't want to get too distracted by testing, so I'm not going to break one and illustrate that. But just feel free to keep this file and look back at it as for options you are likely to want at some point. OK, so line 8, this is how I built the thing. But I really want to run it. So let's go ahead and run this Hello World program. That's how we do it. And if you'll note that printed Hello World. So this is the point where I lodge a minor complaint about Bazel to anyone here involved in its production. A well-behaved Unix tool is silent if nothing goes wrong. This tool is not silent when nothing goes wrong. So I wish it would be by default silent. Wish I had to ask it to produce all that output. OK, so that's that Hello World. So I'm going to take a real slight distraction to how that Hello World happened, because it ties into what we did in the Workspace. In the Workspace, I brought in Guava, a third-party dependency. Now, this is actually because we're doing this on a Google campus, so it's a Google-made third-party dependency, but it's still a third-party dependency. And to actually depend on something brought in by that mechanism, you need something like line 37. So when I'm saying I want to compile some code, like here's a source code I want to compile, I have to list it as a dependency. So again, there's like kind of old naming. So if this was created new today, it probably would say dependencies or libraries or something. It says deps. That's what the name is. It's kind of it's not enforced by Bazel, but it's used across many, many tools. This is a naming scheme specific to the HTTP jar mechanism. In the next example, we'll see fetching using the Maven dependency resolution mechanism. That'll have a little bit different way of doing it. And then in the source code, I wanted to point out, it doesn't really matter because this is not really a Java event. But I didn't actually push it. I did a minor rename and didn't bother to push it yet. But I did actually use Guava to make the most ridiculously over-engineered way of counting the word world that you could possibly imagine. I brought in a Guava multiset to count how many times the word world was mentioned on the command line, so I could say hello world or hello worlds. So if you run the thing which does the hello worlds target passes the word world 3 times. And so sure enough, if I do hello worlds, it says hello world. So anyway, I've shown off my elite Java coding skills. I wrote Java code all day, every day for about 10 years, but that was more than 10 years ago. So there was a time when it just flew out. But things fade slightly. It happens. OK, so I think I've now explained every little bit and piece of this simplest, feasible, single external dependency Java example. Are there any more questions on this one? There's somebody with the mic behind you. We'll let him go first.
So I have two questions. One is, where are the binaries stored?
Yeah, so I had kind of glossed over that by using Bazel run to run them. And I think this is a little bit of a rough edge. At the moment, to understand where things are, you go into the documentation, and if you can find the bit in here about the output directory layout, there is an explanation of where things are. So you should familiarize yourself with this documentation page. There's quite a bit of it. But the short version is, if you just look around, you can usually spot what you want. So I'm going to bring up a copy of a different editor here. Ooh, that did not help, did it? How about this? How about if I do code? I'll bring up another copy of VS Code and see if, yeah, there we go. OK, so in this copy, I don't have the setting that hides these guys. So there's this, I don't know if convention is the word. There's this thing Bazel does for you. It creates 4 symlinks by default inside your workspace. And that way, you don't have to go like looking around outside your workspace to find things like logs and output. It provides symlinks that get you access. One of the symlinks it gives is a symlink back to your workspace. And I have not yet found a good explanation of why this one happens. So I do not know. If there's anyone in the room who knows, please tell me. I do not know what the motivation is for that one. But well, test logs is where test logs land. That's pretty self-explanatory. Bin and out, there's been a lot of discussion. It seems like there's not a lot of clarity on exactly what the difference should be between bin and out. I think there's actually some discussion at some point of whether they should be the same thing. But between the two of those, you can typically look around and find what you want. So for example, that hello world, this right here is an automatically generated bash script, which does the ridiculous amount of push-ups that we have all done by hand to make it possible to run our Java programs correctly at the command line. So this is actually a super convenient thing, right? Writing, like every project I've ever seen ends up with a complex command line wrapper around Java, a Java invocation. And I don't know whether the Google-generated one is fantastic, but I know it's at least reasonably decent. And so it's possible that if you have a project right now, you're building another way with a hand-coded command line wrapper, it's possible that the generated command line wrapper might actually take care of your needs for you. That would be pretty great. The short answer to that question is the things that are binaries do land in bin. And so when I said, let's see if I can just I'll make it as direct as possible. So this build file is at the top of my workspace. It's parallel to my workspace file. And it made a output called hello world. And so this name became the name of something in the Bazel bin symlink. And that thing will have the exact same name, hello world, and it'll have various suffixes after it. So the jar file that command line wrapper needs to run will be called that thing .jar. I do not remember the purpose of the native header, but these are the two most important files here and here to make it work. And if I built on Windows, I would get a hello world.bat, which had a reasonably suitable Windows command line wrapper for it. So did that answer that question sufficiently?
Yep, it did.
Yeah,
and
okay.
The second question is, how do you pass arguments to that binary if you ran it?
So in the context of something I want to run via Bazel, I'm typically passing those arguments in here. Actually, I can close this one now. Like if I'm making a Bazel target to encapsulate running it, I literally pass them right there, where you can see on the screen. I could, though, if I wanted to go run that file directly, let me see here. And I could, if I wanted, make one of these that did not, so that said world, right? Hello worlds. Wait, which one did I run? I run hello world, which is this one, and I mentioned only one world. Yep. So if I say world, it's a single world. If I say world, I say it twice, it's going to say hello to both worlds. So
not from the Bazel run.
Right, because that wrapper, so that target the build output of that target is a script that can actually become the build output of your build process. Like I could CP a couple of those into my output artifacts of my build process, and that would be running them with just at the command line. But when you're running them via Bazel run, they're assuming that you want to control that execution using Bazel, so it uses those args that you pass. Okay, any more questions about this simplest? Yeah, go ahead.
Just really quick, back in Alias, when you define that alias,
okay, you're saying
you defined it in the build file, right? But
right
then
here.
you used it in the Basil Rc. Can it be more nested into your directory structure and Basil Rc will still detect it?
I believe I have not. I put it here because the handful of examples I could find seem to always put it here at the top. The top turns out to be a pretty good place to put it because in a real project, your stuff is normally pushed down in other directories. But if you wanted to push that down, yeah, you could move that down to another directory, like you could make like a JDK directory or something, and then you would have to edit your Basil RC to have a different target where it says to go find the JDK. Yeah. Okay, any more questions about this simplest, complete Java example? Yeah.
So going back to the build.bazel file.
Yes.
So you have written the dependency as at the rate Guava, right?
Tell me a line number.
Okay.
While she's looking for the line number, this is a tip for anyone that everyone has to explain code to other people. Always turn your line numbers on, because it's a lot easier to call out a line number than to point. Yeah, okay, what are you saying?
I think it's either 37 or 47.
37 or 47,
Yeah.
okay.
Yeah, it's there. So at the rate, does it have a significance of using at or slash at the
Okay,
beginning?
so whenever you see something that has this kind of look to it, you're actually looking at a Bazel target. A target has this a label is like the name of a target, and a label has this like the kind of micro language syntax. Unfortunately, because they built this syntax on top of Python, it looks just like a string in the file. So you kind of just have to know that line 37 is a label. And the way labels work, if they start with an @ sign, then they're pointing at another workspace. Well, if I look at my workspace, this HTTP jar basically brought in another workspace off to the side called Guava. And so whenever you see that at the beginning, you could simply take that word and go find it in your workspace, and that would be where it came from. And then, again, you kind of just have to know that the convention implemented by HTTP jar, by this rule, is that it outputs something called jar, which is the actual jar file that was fetched. So it's, in reality, you would only use this HTTP jar in the very simplest cases, because if you have a lot of dependencies, you're going to want to use Maven anyway, and we're going to see that next. Okay, any more questions on the simplest working or reasonable Java program? Okay, great. Now, was everyone able to run this? Okay, nobody's squawking. If anyone wants to make any small edits, if anyone wants to say, go in here and edit the number of parameters or change the name of a parameter or something, feel free to do so. And if you hit an interesting error message, we'll take a pause and try to work through it. There's people around that can help. So I don't have a specific target to do, but just if you want to try tinkering this while we proceed, I would encourage you to do so, because if you hit an interesting question right now, in the next hour or whatever, you'll be able to get an answer. Okay, the next one to look at is number 3. So this is more about Java dependencies. So again, I'm going to assume that you are now an expert in everything we have covered so far, and so just go very, very fast past all the things that are not new. So as always, what version of Bazel are we running? 2.00 RC3. I spoke with someone during the break who thought they were on version 1.2.1, but when they ran the Bazel version command, which I will show, good command to know, they ran the Bazel version command, and they see I'm on 2.00 RC3. they were actually on 0.26, and they were getting weird error messages. It's because they were on an old version. So if you're ever not confident what version is running, it's just Bazel version to find out what version is running. Oh, weird. OK, my Basilisk is 1.10, but my Bazel is 2.0 RC3. OK, so the next thing that happens is the Basil Rc file. This is exactly the same thing as last time. So again, anytime you have a group of related projects, they're going to share some cache. You're going to have something in here about cache. And anytime you're using a Bazel managed JDK, you're going to have a section about the JDK. Nothing new here. At the workspace, so starting at the top as usual, it's got a name. I gave it a different name because that's a good practice. HTTP archive is there. Oh, and a question came up also at the break of what are about some of the other ways of if you wanted to intercept how dependencies are loaded, because inside your company maybe you don't want to load things externally and you don't feel like going and like editing any of your dependencies. You could actually replace the HTTP archive command. You could write your own. You could load up your own variant of HTTP archive right here that looked at these URLs and like munged them in some way to point to an internal server. So there's just endless different places where you could get a little lever in and change Bazel's behavior to do what you want. OK. Lines 13, 15, and 17, you have seen those exactly before. All the stuff about loading the JDKs, you've seen those before. There's a rule set, again, from the core team called rules JVM external. I kind of wish it had been named like rules Maven, because that might be a little more clear name for what it is. But this contains the things you need to go load jars from Maven repositories. So let's see how this works. So for some reason, some of the rules suggest this syntax. You can reason what this means, right? We're just defining a variable here, and then we're using it. Line 61. So raise your hand if you've not used Python. OK, so I will let the one non-Pythoner guess the meaning of line 61, because it's obvious to any Pythoner. OK, so rules JVM external provides a Maven installation mechanism. So as always, before I can use a rule, I have to load the rule from somewhere, and that's just where that came from. So how would I know that? If I walked up to this code one day and I had forgotten anything, how would I know that? Well, if the person who wrote this imported this thing under its kind of standard name, you could search for that on the internet. Or if you just happen to know, in the Bazel documentation, the Java support is here under rules. So you go to the Java part here, and I could make my way in here, and I could find my way to it. I could type rules JVM external there. So there's lots of different. You could basically let search be your friend, right? Although one really important oddity, certain rules, because historically they came kind of as part of core Blaze Bazel from inside Google, certain rules are kind of got a promotion to be on the main Bazel documentation website. So if I go here to documentation and I click rules, I see a bunch of the rules are listed here. But oddly enough, like the Node JavaScript rules, if I click on them, that actually takes you out to this GitHub page, because not all the rule sets being developed by Googlers have been promoted into the bazel.build website yet. So there are a few kinds where you'll find like the documentation for certain things is like on the GitHub page. That's OK. If it's still valid, you can stick clear. You can tell that this came from the core team because it's part of the Bazel build organization. So try not to be alarmed. OK, so let me unwind the stack just a little bit here. So we loaded the external rules. From those rules, we got Maven install. OK, so this is sort of like a POM, but much, much shorter. It's just the external dependency part of a POM. You list your artifacts. Oddly enough, you list your artifacts with that kind of string microsyntax that you would use in Gradle. So if you go to one of like the Maven repo searching sites, and it says, here's the string you used to bring this in for Gradle, that's what you can paste into this artifact list. If you're doing Java loading things via Maven, you probably ought to be using pinning so that you notice if like the hash changes on something you're bringing in. If you've not used Maven pinning, that's sort of like a node package lock. There's an analog for every package manager. But I've done this example with pinning out of fear. Specifically, I've found that any code I put on a slide, someone assumes is perfect, amazing code they should copy into their real production project. And so I would not recommend not using pinning, and therefore this trivial example of using pinning. It doesn't really matter, it's a Maven thing, not a Bazel thing. But the essence is, if you're using pinning, you call a thing called pinned Maven install. And I don't want to spend more time on it, just to point out that the POM, I don't have a POM here. You'd throw away your POM, and the combination of the build files and the Workspace file take the place of a Maven POM as you're moving from Maven to Bazel. And I think this afternoon on the schedule, I think there might be a talk that talks about going from Gradle to Bazel. Does anybody know? If anybody has the... Was there just a lightning talk? Yeah. That talk is more than a lightning's worth of talk. Anyway, so just so you've seen the syntax, right? So by now the kind of the theme of how this works should start to become clear. Really important aspect of learning all this, you only have to go in deep on the kind of pie segment of the ecosystem you're actually using. So if you're not using Java code, this might be the last time you ever even care about the Maven install rule. So I'm trying to spend as much time as possible on Bazel-wide things and as little time as possible digging into the specific rule sets. Because really, you could sort of think of it being as an overall Bazel ecosystem, but then like a sub-ecosystem for each rule set. Like there's a whole bunch of stuff you have to do if you're doing iOS builds in Xcode, which there was a talk about yesterday. I don't do iOS in Xcode. I don't know anything about that stuff. But I don't have to because I'm not in that edge of the Bazel ecosystem. I'm in other parts of it. OK, so we brought this in via the pinned Maven install mechanism. So now we're going to go see how we would use that. So this time, my top-level build file only has the JDK stuff, right? Because you remember I mentioned that each file that has a build file, each directory that has a build file is a Maven module, or a Bazel module, sorry. In a real project of complexity, you wouldn't just pile everything into one build file at the top of your project. It would quickly become, disastrously unmanageable. So instead, you end up pushing the instructions of how to build each piece further and further down, kind of into the tips, into the leaf nodes of your project. So I followed Maven directory naming practices here. You don't have to. I mean, there's no law that says they have to be lined up that way. But just so many Java projects are that I followed the pattern. So here we are. Here's a different variation of the greeter. This is the one that uses that run files mechanism. And that's kind of a Google-specific mechanism. Has anybody ever used the Google Java run files mechanism? I know there's like at least a Google or two in the room. You haven't used it? OK. So I'm going to skip the details of that, which means I can skip this resources directory. The important thing is that instead of doing that Java binary library stuff down deep or at the top of the project, then having long paths to the code, I can put that file down next to the code. See, it's immediately adjacent to the code. And so then when it refers to the source code, it just uses the name. It's right there. You don't have to repeat that long path again and again. Everything in here is analogous to what you just saw, but with shorter paths, because we put the build file next to the code. Now there are caveats around this. I don't want to get too deep into Java, but someone had mentioned yesterday in one of their talks that in their project they had chosen the granularity of one build file per Java package, which is to say per directory. And I think that's a really good default. That's probably a better default than one build file at the top for the whole thing. But you should test performance trade-offs. Because the Java compiler is actually really good at efficiently compiling a whole bunch of files that cross-refer. And so it's possible you might slow down your total build by dividing it into many separate build rules. So you may get more performance by picking a little bit bigger granularity, not a single compile for 70,000 Java files, but it's possible that a separate compile for each group of 5 files might cost you some time. I see someone smiling here. Does that happen to you? Okay. So I smiled. I thought I might have interpreted it as that happened to me. But what I've done here, I only have one Java file, so my granularity is sort of obvious, right? I have one file. I had asked earlier, and Java was the most popular language in the room. So I am happy to take more questions here, but there's one bit. Let me find the important bit. I'm trying to figure out if on this one, I didn't actually do the import, I remember now. So on this one, I had brought in JUnit to use for testing, but then I realized later that when you do your tests here, although I might have referred to JUnit, it appears to me that the Maven Java testing rule puts JUnit in your class path for you. So I think I found last time I did this that I could skip this, and it worked fine. But I left it in here because it illustrates a name mangling process. Remember I said that the things you do in the workspace make other workspaces available. Well, that Maven import process makes one available under the name Maven, which you can see right there. And then the specific Maven package you imported, its name gets mangled to become this part, right? So let's get that in front of us. So when I brought in a thing called JUnit::JUnit with a version number, that got made available inside Maven //:JUnit_JUnit without the version number. It is possible, perhaps with a little effort, to use multiple versions of a dependency inside Bazel. But I would say that Bazel overall, both its design and its sort of ethos, it kind of assumes you're doing the single version policy thing that Googlers talk about regularly. Raise your hand if you know what the single version policy is. Not very many. OK, so the single version policy is the idea that inside a company, you pick one single version of every external dependency, and that becomes the version used for everything in the whole company. And so then when you upgrade that dependency, you upgrade it synchronously for everyone in the whole company. To do this, you either need to be in a giant monorepo or in that kind of the virtual monorepo idea you see floating around. The single version policy is mostly a great idea, but there are also contexts where it doesn't work very well at all. So I'm not saying you have to use it, but by the nature of its design, Bazel would really like you to be using the single version policy. It would like you to be working in a monorepo with the single version policy. And I think that's a pretty good idea. But it's not everyone does it. Who here has a giant monorepo in their company where they work? That's not bad. For the sake of the video, about 10% of the people in the room are in a monorepo. Great. I work in a consultancy. In a consultancy, we have bits of code that belong to many different customers who would not be all interested in us combining all their code into one monorepo. So I am forever cursed to not be in a monorepo myself. Questions?
Yeah, the relative path for the JUnit. So that's going to be inside of the generated.
OK, tell me a line number.
The line is 10.
Line 10, OK.
So this is relative to one of the generated directories in our local space, not in the workspace itself.
So
the original workspace itself.
So at Maven means in the Maven workspace.
Correct.
So in my workspace file, when I ran these Maven rules, unfortunately, this is kind of an irritation. Many rules have a convention that they state a name when you use them, but not all of them do that. So I'm going to leave that there, but commented. Some of them you just have to know that this rule brought in a workspace called Maven. Mm-hmm. And so when I refer to it, / means the root of the workspace. And then there's a convention implemented by the Bazel Maven machinery that makes each dependency available in a name like this, organization underscore project.
Yeah, but
And so-
if you go to the workspace itself,
Yes.
there is no such a thing as unit, JUnit. So you have to go into
Right here.
one of the
No, right here.
where?
When I set up the Bazel Maven rules, I only listed one thing I wanted to bring in from the outside, which was JUnit. So that's where it came from. So you could study the documentation and the patterns for using the Bazel Maven rules. And fortunately, like there's not much to understand. Once you've used this for a day, you'll know the pattern for the end of time. But yeah, that's where that name came from. So it's not relative to the build file. This is relative to the generated Maven workspace that was generated by those rules when they ran. Okay, more questions about this guy? Because we're going to kick it up another notch in the next one. We're going to add a whole new kind of complexity, not yet seen. Okay, so did anybody try compiling and wants any help with any small edit they made? Yeah, go ahead.
This is a Java library, which is, if I want to publish it out.
Oh, so you're saying if you want to get the output. Well, it's actually the same idea.
No, I mean, publish it out to an artifactory so that other people can consume.
Oh, okay, so in the kind of Bazel, Google monorepo way of thinking about the world, like you probably wouldn't do that. but you could do that. There are rules that you can use to do that here. You could just take the jar file and use the command line Maven publishing tool if you wanted. But I believe there's something in there that helps you publish. I have seen and helped companies go down the path of using an internal Maven repository as their code sharing mechanism inside their company. I would say that is a good way to spend a tremendous amount of time and money developing software. It's maybe, I mean, like living through that and the costs that you incur over time with that approach makes a very strong argument for the single version monorepo approach to software development. But you can do it with this. But I would be cautious to encourage that approach.
In the Maven install, the JSON file?
So this is the pinning file. So this is part of the machinery that Maven uses to lock down and make sure you got the exact version.
Right. So there are dependencies and direct dependencies. Is this auto-generated or do you remove stuff out of it?
I did not write this. So if
sorry.
you're using Maven at the command line, it will output this when you tell it to make a pinning file. Or if you're using Maven via Bazel, I included some of the commands you might use to get started in comments. But to avoid getting too far down the path in here, in the short time we have about like the details of the Java support, I didn't actually go through running them here. But if you start down this path, you'll find that these commands are really all you need to do that. One of the commands generates the pinning file, and then the other commands consume the pinning file.
So basically, this will take care of putting the dependencies in the class path as well.
Yes, yep. And so the generated targets, so this generated target right here, that is a target that contains JUnit and all of its transitive dependencies. And that's an idea that we'll see again and again. So in fact, it's hard to illustrate here because we only have one dependency listed. We'll see a variation of this on the next one that's a little more complexity. But there's this idea that at the top of your project, you specify all of your external dependencies. And then at the build file level, you then narrowly define what dependencies are available to build just this piece of code. Right? So it doesn't automatically take all the jar files for all your dependencies and put them on the class path for everything. It only puts the stuff that you asked it to. So here in the build file, I clicked away from get back to the correct build file. Here in the build file, I guess this other build file, I asked for JUnit I asked for genuine and its transitive dependencies. That's very important. Let's say you had 100 incoming Maven artifacts, and there's another 100 transitive dependencies or whatever. If you included all of those in the class path for everything, then anytime you had a version bump of any of your dependencies, you have to rebuild and retest everything. But by narrowing the dependencies, that idea that where Bazel is managing this build dependency graph, it knows what it has to rebuild because it knows what changed, because you told it what changed.
One last question. If there are like a diamond dependency problem where two transitive...
Yeah, okay, so dependency management is a gigantic pain. That's why there was the comment on the main stage yesterday that the Workspace file is starting to look like it might have to grow into a dependency manager, and they really, really don't want to do that because it's a gigantic pain. One of the ways in which it's a pain is the diamond dependency problem. In this example you see in front of you, we are delegating dependency resolution to the Maven machinery for dependency resolution. So Bazel is doing precisely nothing to do with the diamond dependency problem here. That is a giant pain, and that the single version policy frees you. You never hit the diamond dependency problem if you have the single version policy, because it gets resolved kind of by the set of what you chose, right? But yeah, okay. Any more questions on this bit? Okay. We're going to step it up a notch. We've seen Go, we've seen Java. Let's see them together. So as before, I'm going to assume you are now an expert in everything we have seen and go real fast from the beginning. So the Bazel version, I'm using this nice latest and greatest again. Basil Rc, nothing new. This is exactly as you've seen. Now, this is when it starts to get interesting. So now I want to use Java and I want to use Go, because I'm making a multi-language project. Well, that means my workspace has to have all the Java stuff and all the Go stuff. Now, if you've been using this a while, it's not that hard to put together a workspace that has all the Java stuff and the Go stuff. Let me just go through it briefly here. So we start with the HTTP archive. We bring in the Java rules. We bring in the transitive loading stuff from the Java rules, and we invoke it. We go get our JDKs. Now, I'm going to use protocol buffers and gRPC to talk between these two programs. Raise your hand if you know what protocol buffers and gRPC are. I am so happy to hear that. For those that haven't, it is a typed, a schema-based RPC across the wire or to the disk, data persistence, and RPC mechanism. If you're writing code by hand to put stuff in JSON and then writing code by hand to know the meaning of the fields on the other end, I suggest you stop, because it's a really bad way to do it. So I don't know if gRPC is not necessarily right for everybody, but it or one of its competitors is almost always a better choice than doing kind of ad hoc string-based RPC. Okay, so protobuf sits underneath gRPC. I have to know that as a workspace author. So here I am loading the rules for protobuf. Now, did I have to write this? No, I didn't. I went to the GitHub page or the documentation page for the protobuf rules for Bazel, and I copy-pasted this block, and I brought it in. Like the Java support we just saw, it has to load dependencies. So again, it can't load its own dependencies. It has to make available to me a couple of functions, and I'm basically giving it permission to load its dependencies. Next, there's a layer that connects this gRPC RPC mechanism and compiles it for Java. I have to go load that. And it has dependencies. So again, although I was able to copy this chunk from some documentation somewhere, still, at the workspace level, I have to go give it permission or instruct it to load its dependencies. And now, rules JVM external, we've seen that. That's what gets our ability to pull code in via Maven, so that appears. And that's everything down to here. Now, I want to use Go in the same project. So here we are. I just brought in all that same Go stuff again, and I brought in Gazelle again, because why did I bring in Gazelle? I'm not actually using Gazelle, but Gazelle is where the rule lives that lets me load external dependencies for Go, and I wanted to do that. So I brought in Bazel so I could load an external dependency. I let it specify and manage the Go version. So now I could run this Bazel file on a computer that had no Go, had no Java, and had none of the gRPC protobuf stuff. And it's managing bringing all that code to run and compile it. And in fact, it does so successfully, it costs 3 operating systems. So on the one hand, this is like only the 4th workspace you've seen today. On the other hand, this is, I believe, a reasonably correct workspace, as illustrated by it actually works across multiple operating systems. OK, so here we are using that Go mechanism to bring in dependencies. And again, a little frustration, because this top one is this thing called Slim. That's a dependency I'm using. But again, because the way workspaces work, they're not recursive. They can't go fetch, things can't go just automatically fetch their own dependencies. I have to know that if I'm using gRPC with Go, that I have to bring in these 3 things. So you might be thinking, wow, that's now 100. It's only 2 languages and 1 RPC mechanism, and it's 183 lines. And it seemed like there was a lot to understand. And how on earth would I know that I had like versions of all this stuff that's compatible? Has anyone, raise your hand if you've thought that to yourself yet. I'm disappointed only a few have thought that. If you start using this, you will run into this. This is the exact problem that federation that you heard mentioned yesterday solves. So with federation, if these tools were in federation, and since they're like core Google things, they will almost certainly make their way in federation, you would delete this whole workspace and put in a very short number of lines that say, go get me all the matching versions that someone else figured out of these tools, and it would all just work. But that's a great future thing coming for today. If you want to use Java and Go and gRPC, you need something pretty close to what you have in front of you here. OK, any questions about this workspace? So there surely must be some, because it's 183 lines long. Yeah?
Maybe you covered this before, but in the
Oh, can you use that?
how does it know which JDK to install?
OK, so the question was, how does it know which JDK? So that is just brought over from the previous step. In my top-level build file, I'm using the alias and select mechanisms to pick the right one. OK, more questions about this workspace? Cool. OK. We have a front-end program. It's written in Go. Now, again, I'm not a Go developer, so the details of the Go don't matter. I mean, I'm enough of a Go developer to write this program, but I'm not really a Go developer. It's using that Slim thing. Slim is the thing that like takes this like indented form of HTML and like does some substitution. It's equivalent to like, I don't know, ERB or 100 other tools like it in the world, PHP files, whatever. But importantly, it brings in this mechanism here, this protobuf mechanism. So protocol buffers takes an API and generates code for that API. gRPC layers on top of that to generate a gRPC mechanism for that API. And so that code has to be used to compile this Go code, right? So I can't really understand. I leapt into the first source code file, but it turns out that, hey, what is this? This came from somewhere else. Well, actually, the center of this system is this protocol buff thing. So see, about half the people were familiar with protocol buffers. So for those that aren't, it's kind of, well, who knows what IDL is? Anybody use Corba in the good old days? All right, OK. So this idea has been re-implemented a zillion times, and it basically is create a language-neutral way of describing the shape of data and the shape of API calls, and then compile that language-neutral way toward many different language targets. And everybody that does this has a slightly different twist on how they think it should be done. Protocol buffs is an especially nice one. And although this is not about protocol buffs, I want to point out why it's especially nice. When you define structures, you give an arbitrary number, kind of like a slot number, basically, to each field, which means that you can actually rename the fields without breaking binary compatibility. And that's really cool, because in all of the systems, and all of the IDL-like systems that don't have that capability, if you step into an old project, a 15-year-old project based on like the original Corba IDL, every single field has a name that makes no sense anymore, because it got that name when the project started and can never be changed. So a nice thing about protocol buffs, if you've never used anything like this, is that it's more compatible with evolving the names of things over time than other similar tools are. So that's my plug for protocol buffs. The important thing is we're defining a very simple API. So there exists a service, and you can add an entry to it and get a list of it, and it's a grocery list. I gave it 2 different RPC calls you could make because one didn't seem like enough, but I didn't even implement the add entry version. So my very simple service gets a grocery list. This is definitely a sledgehammer being used to swat a gnat here, to use gRPC to get a grocery list, but hey. Okay, so the details of it don't matter, but this can be compiled into some Go code and some Java code, which make it easy for one to call the other. And it is as typed as it can reasonably be. So let's see how that comes together. So we need to do some building. We need to run that tooling that converts this protocol buffer thing to a Java thing and to a Go thing. So we've seen enough of these files by now. You can probably read them, right? So load. Well, load loads things from the workspace. I won't go through it, but I could take each of these identifiers, and I could go search in the workspace to see where they came from. And if you step into a new thing and you don't recognize any of these, I would recommend that's what you should go. Figure out where did that come from. Then you step into things you just have to know. So you just have to know that the protocol buff rules expose a thing called Proto Library. And Proto Library is the first step. So that's the first step of compiling a protocol buffer file into sort of the generic binary representation of a protocol buffer file. That's done here. Now, I don't need some kind of generic representation. I need a Java and a Go representation, like a Java and Go encoding of that API, because I'm using it to talk between my Go program and my Java program. Well, here is the rule for taking the protocol buffer stuff and making it ready to use with Go. Again, the details don't matter. And the interesting thing is, as a build engineer on a project, you kind of don't care what's you just care that you're using the right rule for the situation. You kind of don't care what's happening inside it. I could go dig into the documentation and figure out what exactly all this means, but it kind of doesn't matter. All I know is it's going to produce an output under the name API Proto Go. And if I go look at that Go code, it will have defined a dependency on API Proto Go. So all I needed to know is that was the right thing to compile that code ready to consume in Go, and then I need to take that as a dependency when I'm compiling my Go code. Another example of a label, so // means the top of the current workspace, API def means go in this directory, and then colon means go look in the build file in that directory for a thing called API Proto Go. So line 9 refers to line 14 in this file, and it kind of recurs across by name. If I renamed one of these, I would get an interesting build error that it couldn't find the thing, but I don't feel the need to create that build error right now. That's what our exercise is going to be. Our exercise on this one is going to be rename something and unbreak the system. OK, so then for 4 reasons that I do not know, in the Go support for protocol buffers, a single rule handles the protocol buffer and the gRPC. The Java rules, you need a separate rule. You need one rule for the protocol buffers and a separate rule for the gRPC. Now, again, why that is, there's just some historical reason, right, of how it was written. The important thing is, I could go read the documentation, which I did. Then I invoke these things, and now I get generated the Java code I need under that name to consume this from Java. So now I have this API defined, and I've generated Java code and Go code going different ways. I'm going to consume it from there, and then I'm going to be able to call one to the other in this typed way. Now, here's the Go side. Again, the details, here we go. So right there, so I import, so the thing that I generated, I had told it to generate it under the name, see if I can spot it there, under the import path Proto Grocery API, so that then when I imported it in Go, there's the name Proto Grocery API. And then this is just a local alias mechanism if you want to have your own short name for something you imported. And then if I would read through here, I could see this is me calling the Go mechanism for how I like talk to something that implements this grocery list service. So again, if I was giving the all-day explanation of this, I would go through this line by line and why, but it kind of doesn't matter from a Bazel point of view. All that matters is somehow this code ended up here so the thing could compile and run. And then from the Java side, which I called service, there is something, let me see if I can find, there we go. Same idea, those Java dependencies that got generated by the Bazel stuff over here is now available over here to consume from the Java part of my build. So I have a common part of my build, which defines an API, and then I'm like compiling that and making it available to this Java code and Go code. So any questions on like the basic idea? I'm trying to give like the fastest possible explanation of the overall idea. So I'll take a question or two. I know several people were using gRPC. Raise your hand if this makes total sense because you use gRPC. I wish I saw more hands. OK, ask me a question that would clarify what's going on here. Lance, you can be a ringer if you have to. Why is it not obvious? Why is not everyone raising their hand? What's going on here? Any ideas? Maybe if I just run it, maybe that'll make it more clear. We'll try that. OK, I would encourage you to do this on your own machine. As usual, the exercise file has everything you need. You can build it with Bazel build. Oh. So Bazel build ... builds it all. And I happen to know it'll build, so I'm not going to sit there and watch the build run. The important thing is I want to be able to run the front end and the service and see them talk to each other, right? So I mentioned Alias earlier. It's not fun to like type a long label in, / app blah, 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 blah to the thing you want. So even though I defined how to compile my Java code way down deep inside this directory here, you see this really deep directory structure, I have chosen to make a top-level alias. So here I am making a top-level alias to my service. Right? So my top-level alias lets me, from the outside world, just say :service, because this is at the top level. And then it'll automatically alias that to the actual build file, which is deep inside, or to the actual target in that build file. So let me see. I need to unwind my stack of open files here. OK, so Bazel run front end, run the front end code. Service will run the service code. And I have to do those in separate windows. This should work. For everyone here, it should work. So here in this tab, I'll run the front end. Oh, I guess I have to allow it to listen. In this tab, I'll run the service. I guess I have to let them both listen. I wish. It seems like as macOS now makes me answer that question a lot more than it used to. And then my front end is listening on port 8080. And so if I go talk to port 8080, I can see my shopping list. So I'm supposed to applaud at this point. So obviously the functionality is not what's impressive. But let's go trace through exactly what was happening there, how that actually worked. So this is my front end directory, has my front end Go program. The important thing is that if I search through this program for example, bananas, it's not mentioned, right? So the data, I have not inadvertently hard-coded my grocery list into my front end. Instead, in my front end program, I called this get list, and the machinery around it doesn't matter. This is all gRPC irrelevant details. The important thing is that I use this gRPC mechanism to call this get list call, to find it in the protocol buffer file, and then I'm calling it in a typed way here. See, it's typed from Go, and then over in the Java code, I used this implementation base that was generated for me. That gRPC mechanism like makes your base server that you just extend and build on. And so I was able to simply override the generated kind of empty get list implementation. And again, some of the details here have to do with like how the types are generated for Java. And there's a lot of reasons why that's not quite as simple as it might ideally be. But the important thing is that I'm actually providing this data from this end in the Java code. So there you have evidence before you that my front end called my back end using gRPC. So again, the gRPC isn't what matters. What matters is you're now starting to look at a realistically complex workspace. And so this ended up at 183. The interesting thing is that the complexity of this workspace is almost entirely a function of how many different technologies I used. If I replaced that one source file Java service with 25 different microservices, each of which had 10,000 lines of code, it's quite possible I would not edit a single character in the workspace file. So the workspace file's complexity is a function of how many things you're using, not a function of how much you're using of each one. Whereas if I implemented 17 more of these services, I would put a build file next to each one. And I wouldn't have to like edit one single file to know about how they relate. I would just put it all right there. And so you have like a sprawling team making a bunch of changes. You don't have the kind of merge conflicts you would have if you were managing it all in one file. It's all very suitable for use at scale with teams, that sort of thing. Okay, so I have an exercise. Actually, I have one more thing to show, then I have an exercise. Let me see if I can find this thing. Where on earth? Where's my Bazel file? Yeah, OK. So when I did this API definition build, I started to notice, like, that's getting a little messy. I mean, it's only 4 rules, right? But like, let's say that I had like 15 more of those, right? Let's say I had a bunch of those. Big project, right? Do I really want to have like a bunch of different copies? And like, look at this naming convention. This is kind of painful, right? Like I had to figure out how to like make up a name with these suffixes with Go and Java lib. Did anybody notice this yet? Is anybody critiquing my code as you saw this? That it's like a lot of little irrelevant details in there. If I had to do this again, you can imagine like having to carefully edit a file to make it like this file, but like with maybe like search and replacing the word API for the name of a different API. Has anybody spotted that yet? I was hoping someone would feel uncomfortable with this file. Well, there's a Bazel solution for that, and I've put something at the bottom here to illustrate. So what I'm going to do, and you're welcome to follow along, I'm going to take all this stuff and just comment all of that out. And then I'm going to take the thing I have at the bottom and I'm going to uncomment it. So let's say I was working at Acme Corporation, famous from the, I guess, Bugs Bunny cartoons. And they had corporate standards of how Acme Corporation does protocol buffer gRPC interfaces and how exactly they want to do the naming. So remember I mentioned, so workspace files are how you bring stuff in to your workspace, and build files are how you specify what you're going to make in your workspace. BZL files are how you extend the whole thing. So what I've done is this is a rules directory. I've made like kind of the simplest reasonable BZL file. So here I am, I'm extending Bazel in a sense by defining the Acme way of doing gRPC. Now, I don't want to dig into like the syntax details of Starlark too much. It's a Starlark file. It's the name of this language. But the simplest thing you can do in Starlark, kind of the least power step you can use when you're getting your feet wet writing your own BZL files, is to make what they call a macro. Now, a macro is just a function, right? It says def, like if Python people, right? That's just a Python-like function, right? So macro simply means a way of writing one thing that then expands out into a set of things. So in this example here, I've simply done some syntactic edits, right? I've loaded in those rules, and then I've said, well, like, take the name that I was passed and make that the name of the Proto Library, and then add the underscore Go to it and make a Go Proto Library, and then do the same thing with Java and so on. So basically, I have I've made a kind of corporate standardized implementation instead of a concrete human following a naming pattern. I've encoded how to follow that naming pattern into a macro. And I would definitely recommend, before you try to do like your own custom rules, start writing macros. It's really easy. I basically copied and pasted this stuff in here, and I indented it a little bit, and I edited the syntax a little bit. I don't want to dig into the details here because we're at 30 minutes from the end, but it's really easy to get your feet wet here. And then this is like a gentle on-ramp to where you're writing your own rules. Writing your own rules is considerably more complex, but if you get comfortable writing macros, in a few weeks you'll be ready to start writing your own rules. Okay, so I want to try one. I want everyone here to try one exercise if you have it up and running anyway. So I'm going to put this back the way it was. I want you to try just renaming one thing in here and then make your build run again. So pick any of these things, any of these names, and just make some edit to it and then try to make things work again. And that'll put you through the exercise of understanding how the names link together. So the one I'm going to try naming is this one. I'm going to try renaming Java lib, and I'm going to name it I'll at least follow the underscores. So I'm going to try renaming mine this way. So if I go over here, I can kill these things. So I just tried renaming in a place, and I got told there's no such, oh, gross. I mean, this error message, right? It initially seems very overwhelming, but if you just start following your way through, oh, it's in that service source main. Yeah, it's in that Java build file, and it's telling me there's no such target API def lib thing. Oh, that's the thing I renamed. So it turns out I was only referring to this name one other place. And so for my edit, and I would encourage you to do a different one, I'm just going to go in to that build file to where I refer to that Java lib and refer to it in the same way, matching the name, and see if I can now build. So I would encourage you to try a different one, because now you've seen the exact edit for that one. So we'll pause for like 3 minutes here for people to try a rename and maybe hit an interesting question. If somebody wants to ask something unrelated while we wait for the renames, you have 3 minutes to do so. Yeah, you got one up here. He's going to get to the microphone. They're trying to do a recording.
So yeah, I'm kind of confused on like rules and macros. So macro is basically like a function that you would load other macros within, like native macros.
So the things that we're using here are like they're called rules. Let me go back in here. So everything we're invoking here, this is the Proto Library rule. This is the Go Proto Library rule. So a macro just wraps up one or more rules and like somehow translates or expands the parameters in some way.
Oh, okay.
And so a macro looks just like a rule from the point of consumption.
Yeah.
In a sense, it is a rule, but like it's a simplified kind of rule called a macro. So I spoke with several people here. I just asked them because I saw them doing a talk. And of the several people I talked to, they all were doing something vaguely like this idea, where even if they were mostly using off-the-shelf rules, they were like wrapping them in at least some trivial way to implement some aspect of how they want to do things as a company. It's a very, very common thing in Bazel.
Isn't it true that macros and rules are evaluated at different phases of Bazel's build? The rules are evaluated during the loading phase, and
So
macros at the execute.
The challenge is that the macros run before the phase of Bazel execution where the errors are going to happen. So if you get an error, the error is going to be based on what the macro output was. So like if I saw an error, my error would not mention Acme gRPC. It would mention Go Proto Library, and it can be harder to figure out, wait, it's complaining about Go Proto Library, but I never even said Go Proto Library. there's a command line switch, which unfortunately I can't remember off the top of my head. There's a query you can run that'll help you translate between them, help you translate to the code you wrote that triggered it. But yeah, this is not without peril. I'm not saying it's perfect. I'm just saying that it's common.
So macros can also call other macros?
Yeah, this is it's not quite a Python function, but it's pretty close to just being a function. There's nothing to stop you from stacking them as deep as you want.
Is there any editor support for like code completion or telling you that you messed up?
I think this is, so you should be using Buildifier. That'll tell you about the trivial ways where you messed up. But in terms of complexity, like actually IDE, like a language server that processes it, I think that is a contributors welcome area in the Buildifier world. They'd be really, if you would like to step up and be the person who writes the language server protocol implementation that replaces Buildifier, that would be fantastic.
Sorry, this is more of an answer. I've tried a bunch of them. There's IntelliJ plugin, so if you use JetBrains IDEs, you can use it. But I think I found the most usable one in VS Code. VS Code editor has, I think, the best Bazel support built in.
Yeah, that's what I'm using, and it still is nowhere near what you're hoping for. Okay, did anybody raise your hand if you renamed something successfully? Oh, that's not bad. Raise your hand if you want a few more minutes to work on a rename. Okay, so everybody else is just following along. That's great. Okay, so if there's no more questions, we're going to see what else we can talk about in our remaining 24 minutes. Okay, so everything we've seen to this point has been Java and Go. And those are relatively mature. They work great. They've been in use at Google for many years, building huge code bases. And this code is derivative of what they use for real. This is all much less true on the full stack end. So we're not going to go in as much depth on this one, but I want to at least get through a workspace for a full stack program, where full stack means, yeah, there's some Java code running back there for a server, but I'm running a JavaScript-based front end. Now I'm actually doing a Angular front end on this example, but I don't know that we'll even get into the Angular part. I want to go to the top here and just point out some features that come into play. So if you're familiar with Maven, but not with NPM, you could think of the NPM ecosystem as like the Maven ecosystem, but with a much larger number of much smaller packages and very broad and deep transitive dependency trees. So I mentioned, actually, you know what? Someone remind me of the Unix command to count the total size under a directory. Is it like du dash? It's du, but it's hs. Is that it? Oh, that's not bad. Yeah, so I really trimmed this one down to get it to only 424 megabytes of transitive dependencies. On our real projects we do for customers, we're usually at 700 or more. By default, something like a dependency load, that's like a build rule output. So that's going to be hidden down inside that Bazel out mechanism. But my IDE, I want IDE support for all those dependencies. And so they have added this mechanism that basically lets you expose something that's generated as a Bazel target, like the npm load output, npm install output, and expose it as a symlink in your project so that your IDE can see it. That's what line 3 is. I don't know if this mechanism is in use for anything other than the Node ecosystem, but I think it's a general mechanism. I don't think it's limited specifically to Node. So that's what line 3 is. You'll probably only ever see that if you're doing JavaScript. They just announced that at lunchtime there's a birds of a feather, and I'm really curious if anyone's even there, because I think on all the Mang talks at this and the last BazelCon, I think everybody was using languages other than JavaScript. I don't remember seeing anyone. Yeah.
Just to help understand line 3, so the @npm rules or whatever, that's generating a node module somewhere in the whole private output area, and this line 3 is saying to symlink that
Yep,
in?
so that's saying when later you see that I ran a rule that made an NPM workspace exist, make that available to me, the user, under the name node modules, because that's where I need it to be so that my IDE can see it. Yep, okay. So line 3, that's this. So everything on my screen here is stuff we have seen before. Again, so I said this is a Java plus JavaScript project, so you get this thing where you get kind of your workspace is like a mesh of both. Again, you could solve it. You could actually put some of this in separate BZL files and use a load mechanism like we just saw. You could wait until Bazel Federation comes around and does some of this for you. But for the moment, yeah, I'm just piling it all in there. Then I'm trying to get to the right place before I start. OK, so this is a new twist. So in the examples we saw for Go and for Maven, we were using the workspace to load Go code and Java code via Maven, which were then consumed only in Go or in Java. There's a very interesting twist that's present in the JavaScript support. So first, some just things to get past. It's called rules Node.js, but it's really rules JavaScript. It has browser-side JavaScript support in there. It's just a legacy name. So this is like less than a year old, but it has a legacy name. Maybe if we all ask Alex Eagle to rename it, maybe it'll get renamed. So from there, from that, so I made it available. Then again, I said, now reach inside the thing I just downloaded and get me some things out of it that I can call. There's node repositories and yarn install. OK, so node repositories. I do not remember why this was named repositories, but this has the effect of going and getting me a node. So again, just like I managed my version of Go and Java through the Bazel mechanism, instead of just relying on whatever happens to be on the machine, I'm using Bazel to go get nodes. I'm saying, go get a managed copy of node and use that to run everything I need to run. Most rules, you say name equal as the first parameter, and that makes it obvious where the result is published. For reasons unclear to me, the node repositories rule does not take a parameter called name. And so I put it there in a comment just as like a reminder. Pretend that it said that. So if I want to reach in and grab something from what I installed, from this copy of node I installed, that's the name I would do it under. Next, there's a yarn mechanism, right? So this is saying, so go run a yarn install, publish the results under the name npm, which ties back into this npm. Those are the same npms. So go run me a yarn install. And then here's a package file, here's a yarn lock. And then you also need to do this symlink thing this is part of turning on that mechanism. So symlink that out where I can reach it. OK. Now here's when it starts getting good here. So with the Go code and the Java code, I was only pulling in Go code and Java code via that mechanism. For the JavaScript mechanism, they have chosen to publish Bazel code, Bazel rules, to NPM. So there are packages published to NPM that have Bazel rules in them. So I'm like doing like a kind of a double layer of indirection here. So I'm saying, here is a package file with a yarn lock. Use that to go load stuff from NPM. And then this says, by the way, there was some Bazel code in there. Go load that code also. And then because of that transitive thing, there's no way of just like having this single thing, just do the whole, like it can't just transitively grab all the transitive dependencies. So you kind of have to know that is going to expose things that you need to go load further dependencies. So at the moment, I believe the only documentation of this is the published example set in rules Node.js. But again, look who we have in front of us. Federation will, in theory, make all of this much better. We should all ask for more resources to be poured into Federation as fast as possible, because it will make so many things so much better. OK, so for the moment, though, there's this double indirection that's happening. So first, we're going to go pull some stuff from the NPM repositories. We're wondering what's in there. Well, the Bazel team is pushing stuff out under the Bazel namespace on NPM. And so the Bazel TypeScript support instead of fetching that via that HTTP archive mechanism, which you will see, if you look around the web, there's blog posts talking about using HTTP archive to fetch TypeScript support. That's actually obsolete at this point. You don't do that anymore. Instead, they have published that into the NPM ecosystem. And so this goes back to that comment on the main stage yesterday about Workspace probably shouldn't become yet another package manager. So for the JavaScript side, they are going down the path, and I don't know if this is like the ultimate answer or just a step in an evolution, but they're going down the path of just relying on the existing package management ecosystem, relying on the existing dominant package manager in that ecosystem and just putting the Bazel stuff into it. And so it's a little weird because you're like going back and forth more than once, but it seems to work. Okay, and I want to leave our last 10 minutes for just discussion. So we're not going to get all the way through this example, but I was concerned we wouldn't even get to it at all. I'm going to find the extra bits. So even things like protractor, running a protractor test, which they have under the web testing name, like they'll actually go and like put in some browser installs for you to run it on. It's pretty slick. Pretty slick. There's a lot of machinery here, and like this machinery currently works on multiple operating systems. That's pretty good. And then lastly, the last thing, I'd mentioned that IDE integration is a pain. So one of the paths to do IDE integration is to take what's in your workspace and build files, process that code, and then emit like kind of the older equivalent to it. So there is some machinery. I don't have this machinery running in here. I just brought it in here so it'll be here for discussion. But there is machinery that will look at your workspace and build files and spit out a Maven POM that corresponds to them. So if you have an IDE that understands how to auto-configure itself from a Maven POM, but does not understand how to auto-configure itself from Bazel, which I think today is most of them, then there is this kind of workaround, and that will hopefully get you through until the official Bazel support comes through for all the rest of the IDEs. Yes?
The other room finished early, so at lunch. You don't have to finish. I'm just letting you know.
Oh, perfect.
If you want to finish early, you can.
I actually just reached the point where I'm not going to try to present the details of this example. I just wanted to get to how this double dependency mechanism works. And so I will yield the remainder of the time to Q&A. So I will stay in here till the end, but anyone who is super eager to eat can make a run for it. So Q&A.
This is an odd question, but you mentioned that you're not dealing with a monorepo in your work.
I work in a consulting organization,
right?
Which means that each of our customer stuff is a silo unto itself.
Right.
There is no way it's ever going to go in the same repo. Yeah.
Okay. Let's just say you didn't have any legal issues or whatnot, and every customer was happy to have not a single repo, but multiple repos, but you would have to build one Bazel pipeline. How would you go about doing that? Or would you do that?
That wouldn't make sense for somebody who's supporting unrelated projects, because the probability of all your unrelated products being on the same version of Bazel even is really, really low. There are things that make you have a separate workspace, a separate build pipeline. It's like if you literally have one project stuck on Bazel 0.26 and another that's on 1.2, yeah, they're going to have to be pretty separate. Yeah. Was it okay?
I'm doing something that's maybe related to that question, which is, I work in a consulting organization. I have a couple of different customers who happen to be using Bazel, but they're siloed, like you said. I'm publishing a small bit of code that they both would like to consume, and so I actually publish a Go module with a build.bazel file already in it.
Sure.
That's got the exactly set up the way I want it, and it's easy for them both to suck it in.
Yep. Yeah, there are people doing that with Git submodules also, kind of building a virtual repo out of a bunch of submodules. Virtual monorepo, basically. Is there another? Yeah.
That just made me think about something else you mentioned earlier. Somebody asked about pushing artifacts out to remote endpoints. And then having remote caches and remote, right? Everything is local so far in the examples you've shown.
Yeah.
But you can point to endpoints that are not local, is that correct? So you can
Yes.
have that shared caching and shared.
Yeah, absolutely. And
Okay.
so I only showed you caching so you know it's important.
Right.
There are other more advanced talks about like the kinds of caching. Like you can set up a Google Cloud Storage bucket to be your cache. You can just have like something on a shared file system as a cache. There's 2 or 3 different open source implementations and a caching protocol between them. So there's a lot out there around caching. I just did the simplest thing. I brought this up to point out, let's talk about pushing. As you might guess, the Kubernetes stuff is pretty slick. You can actually like manage a Kubernetes deployment from a Bazel rule. It's pretty slick. It's worth looking at if you do that sort of thing. Anybody else? We may have reached the end. So I will point this slide out again. So if you work somewhere, you want like a 4 times long version of this, you might want to call us. But other than that, thanks for coming.
I think you want to go back. Some people were trying to take pictures of that.
Oh, sure, OK. If you want to be, I mean, you could actually like grab a piece of swag and a business card off the desk if you want the lo-fi way of achieving the goal. Or you can take a picture, that's fine. But anyway, so thanks for coming. Hopefully this kind of met anybody's needs. I'm trying to think, I'm just going to stick my email address on here. If anybody wants to just reach out to me directly, I love getting feedback of any form. So feel free to email me directly for feedback of any form. If there's anything you say, hey, I think you should have covered topic X in the first 3 hours, I would like that feedback. If you say it sucked, I'll take that feedback. If you liked it, I'll take that feedback. And yeah, thank you. And lunch has started, so run to lunch.